everyone, I'm Tom and welcome back to Simpson Associates Big Analytics Query. Today we'll be talking about Splink. I'm joined with our very special guest Barney. Barney, welcome. Why don't you introduce yourself and tell us what Splink and data record linkage is.
It's a lot of a mouthful.
It is a bit.
I'm Barney. I work for Simpson Associates as a consultant. Prior to that, I have a history in local government, working in adult and children's social care, and in the NHS, working in various areas of healthcare. And since then, I've moved across to Simpson Associates, doing similar tasks from the other side, helping that kind of organisation get better use out of their data.
Today we're talking about Splink and data linkage, and you're a bit of an expert on it. Why don't you tell us what data record linkage is to start with?
So record linkage, avoiding the obvious that it's about linking records. Typically, the implication is it's joining the same thing or identifying the same thing in multiple places. So, for example, you may have two record systems. You might have a schools database and a social care database. You might have NHS lists. You might have a customer mailing list and a customer purchase list. And you know the same people are in both those lists. There's a lot of value in joining them together so you can analyze between both of them, but it can be really tricky in linking those data and being able to say, this person in this system is the same as that person in that system, and joining together so you actually understand the full picture about what's going on with that person. Also on the side, there's the potential of linking within a data set, and that usually means duplicates. It's quite easy for the same person to be entered multiple times into your mailing list, into your customer list, and it's very useful to be able to identify that person across all the letters, all the different rows, so that you can pull them together and either fix them, get all the information in one place, or simply in terms of reporting, being able to understand that's one person, not three people.
So we'll be talking about that and using Splink, open source software. And other than a fun word and a word that I can actually say, what is Splink?
Splink is a Python library. It was produced by the Ministry of Justice, and we can talk more about that history in a minute. But essentially, it's a block of software, a block of code that will plug in to Python. So once you're set up, if you have a little bit of familiarity with Python, you don't need a lot. There are a lot of good tutorials on the Splink website. You can start using Splink as a tool to match across the record systems. And it's a full library. It's not just a sort of one trick. There are features that will allow you to analyze the data sets, to understand what you think the commonalities are between the data sets, what the differences are, to start identifying how you'd link things together. And then the real meat of it is actually the linkage tools. Splink goes through a process of probabilistic matching. And what that is you set up Splink so that you can tell it, here are a set of things that you need to understand, need to be compared. It could be a person's first name, their last name, their date of birth. You're defining how you might possibly compare them. Not just, is my name the same, but is my name similar? Take me, for example. I'm Barney, and I spell my name with an EY. But some people will miss the E. So it's not exactly the same. Some people will spell it with IE, which is an even further step away. If you turn closed captions on for this YouTube video, you'll find it's probably calling me Bernie. And the tax man and my mother call me Barnabas. All of those are me, but they're formatted differently. And Splink gives you that facility to not just say, this is the same, this is the difference, but to look at a graduation in between. Drop the E, that's one character difference. IE is two character difference. Barnabas, it's a big difference, but you've got kind of a bar in there. So you can say you've got a leaning. And Splink gives you all those tools to work those out, work how significant that is, and then push everything together to give you a likelihood that one record is the same as the other record.
Sounds very powerful with a lot of different assets to it. You mentioned the history of it. Why don't you tell us the story of Splink? How did it first come about?
Splink started out at the Ministry of Justice. Ministry of Justice, unsurprisingly, they have a lot of data, and it comes in from a lot of sources. And equally, it's very, very important that they match the right person up across those data sets. If they get it wrong, you could get into trouble, or someone else could get into trouble. So they went away to find what the best way of they could approach to match their data, and they set a series of criteria. They needed something that was cost effective. They needed it to perform really, really well, because Ministry of Justice potentially needs to handle 100 million odd rows, everybody in this country with a few duplicates and a few extras. They also wanted whatever process they use to be clearly understandable. They knew that when they were presenting these results out, they needed to be able to explain it to other people who are less than technical. And they also needed it to be flexible enough to be able to do it in multiple places. They needed the option to be able to run it locally while they're developing, and then push it out to something very big in the cloud to do a very large amount of processing. When they looked at the landscape and they studied the products available, they unsurprisingly found absolutely nothing that would meet the requirements, certainly not in the price range they were looking for. So they went away and they applied to a central government program for funding to develop open source projects to solve problems within government. And they received about, I believe it was around £60,000. And with that, they built the first version of Splink. They published it as open source, and they've been developing it since there. And it's snowballed since then. Originally, it was just Ministry of Justice use, but it started to spread across government uses, healthcare uses, and then more and more in the commercial world. People like us are picking up as a good option, as an alternative to the more commercial packages that we would have used historically.
Great, thank you. And so, looking more kind of technical, how does Splink actually work? How do I get it working for me?
To understand how Splink works, we probably need to rewind a little bit and kind of work through how you might approach matching records without Splink. And the first step is called deterministic matching. It's deterministic because you're looking for an actual physical direct immediate link. You're looking for Barney equals Barney, letter for letter, exactly the same. And you may well start with this. You'll have you have two databases. You can write a query and just say, find me all the people whose first name is the same, whose last name is the same, whose date of birth is the same, whose address is the same. And you'll find quite a lot. You might get 60% of the matches you need, which is good, but it's not as much as you want. And so you would start thinking, what can I do next? Because you'd be looking at examples, and you maybe look yourself up in the data set, and you can see this Barney and Barney, this Barnabas. Maybe you can see you've moved house. And you would find ways of putting a little bit flex into that query. And that's where we come into fuzzy matching. Fuzzy matching is where you're using various tools, various functions. People may be familiar with the names. SoundX is a way of showing that two words sound about the same. There are functions from various people with usually very interesting names. Yarrow Winkler, Levenstein distance functions. All of these are about looking at pieces of text and saying, how different are they? How many changes do I have to make to go from one to the other? And so now you've got room to start adapting a little bit. You can say, find all the people where the surname is the same, and there's only one letter difference in the first name. And so that will pick up the Barney, the E versus the EY. Two letters will get the IE. And you just play around. You go lots and lots of options, lots of these different fuzzy options, and you'll push them all together, and then you'll try and think of a way of deciding which one is the best signal. Is an exact match on first name and a fuzzy match on last name better than an exact match on last name and a fuzzy match on first name, or vice versa. And so you're getting a lot more, you're finding more matches, you're up to that 80%, that 85%, that 90%. It's really just a question of how many of these rules you write. You could get probably exactly as far as Splink does. The problem was it would take you months. It would take you years, and you would have an endless debate about which rule's better. Is this rule better? Is this rule better? There'd be no way of fully judging it. And that's where Splink steps in with probabilistic matching. Splink does the same as fuzzy matching. We're defining those comparisons, but rather than writing them one at a time, we're writing them all up front. We're saying for a first name, you could have an exact match. You could have it completely different. And you can have as many graduations in between. And Splink will factor all of those in, and when it does its comparisons, it will decide which level hits. And then the other thing that Splink will do is, by feeding in the data sets, by letting it compare things, by giving it a list of comparisons that you know definitely aren't the same person. Hopefully you have a list of some people you know definitely are the same person. Maybe you've recorded NHS number against some of your records, but not all. It can understand what an actual match looks like and how that text can flex. It can generate a probability for each of these comparisons to say how likely these things occur. So we're no longer judging as a human being which ones we think are best. We're generating an actual mathematical picture of how close this is. Is this a positive signal? Is this a negative signal? And then ultimately, for every field, you're weighting it, saying, does this make it more likely this is a match, or does it make it less likely? Splink can then run that for every field. It's generating that number for the first name, for the last name, for the date of birth, for the address, for anything else you can give it, and then it will add them all up. So ultimately, you've got a weighting. And if you've got big weighting, it's a really good sign it's the same thing. Got small weighting or negative weighting, it's a sign that it's probably not the same thing. Then you've got those results out there, which you can then start using to interpret and feed further on to say, these are definitely the same people, these are definitely not the same people. And also that there's a fuzzy area in the middle. Yeah. That sometimes being a bit wrong doesn't matter. It's more about research, it's more about getting breadth. Sometimes it's really important to get exactly the same. So you can start analyzing those middle areas further and feed them down to a human being. But the good news is, because you've done a Splink and you've done that matching, you've already taken out certain matches, you've ruled out your certain non-matches. Your human being, rather than looking at 100,000 records, is looking at hundreds.
And I guess with them, then it depends on what the use case actually is, as to how strong a match needs to be, how certain it is. And then you get that flexibility with your own solution to say, I need it this much matched, or this, like the quality of match can determine on what you're sealing your data with.
Yes, exactly. If you're running a commercial project, if you are, say, trying to work out who should get what advertising, if you have a few mismatches, it's probably not going to matter. If you've got 3 different letters on a mailing list, one sells the expensive product, one sells the cheap product, one sells the middle product, and you accidentally send the advert for the expensive product to the person who you think can't afford the expensive product, it's not going to be the end of the world.
Yeah.
If you're the Ministry of Justice and you're matching up 2 records and the police are going to be knocking on the door because of the result of that match,
probably want to get that one right.
Yeah, you want to get that one right. Yeah. It's going to be embarrassing at minimum.
And do you have any stories of using Splink in customer cases? Are there examples that you've got of real uses?
Yes, certainly. So the main use I've been involved in is with a government program called Supporting Families. Supporting Families is a program that was introduced towards families, but this largely sits with children's social care as a way of dealing with the issue. And I was on the other side of this when I was working in children's social care. You'd look at all these records, you'd look at the cases that were involved with social workers, you'd read through the history, because often we were doing data queries and we had to read through the full history. And once I remember talking to one of the senior social workers and saying, why did no one do anything before this? I've read the notes. You could see this happening. And her answer was just simply, there's no one to do it early. The social workers are paid to clear up after things go wrong. At the time before supporting families came in, there was no budget, there was no support for the early identification. And the early identification can be difficult because it's not in one place. You don't look at one place and say, this is a problem that needs help. It's a lot of little signs. And that's where Splink has started to come in against supporting families. Splink allows us to link up multiple data sets and look at all of those little signs. Maybe there have been a few contacts with social care, but they've fallen below threshold. Yeah. Perhaps we look at the school attendance and the children have been suspended a few times. Maybe their attendance is falling a bit low. You check the police records. Maybe there's a record of domestic violence. You get benefits data and you see that the parents are unemployed. None of these individually puts a family at risk. But what supporting families says is if you identify 3 of these, then you've gone above a threshold and you can qualify. The government will immediately put funding in towards working with that family. The social workers, then there's a mechanism whereby they can employ people and they can work with that family, and they will track that family through with that combined data set to hopefully at the end of the process be able to say the work has been successful. School attendance has gone up, suspensions have gone down, we're not seeing calls out to the police. And at that point, there's a second payment coming through the process to reward the success of the program. And in many ways, this has revolutionized a lot that social care process, because the first time you can genuinely fund, you can genuinely identify, and you can actually work towards that preventative approach rather than coming back and dealing with the mess after it's happened. And Simpson Associates has been quite regularly involved with those projects because, as you've been picking up from all that talk, I'm mentioning a lot of systems, I'm mentioning a lot of parties. Genuinely, everyone will write their name slightly differently, and it's very helpful for us to come in to lay out Splink. We'll use their expertise in terms of understanding the data and understanding what's important, and then we'll use our expertise to get them the best possible matches to identify the largest number of people across the systems, to find the most families, so that they can firstly prioritize the most important families, but also find as many as they possibly can so they can increase that funding.
Sounds great work.
Yeah.
How would you recommend starting out? I think we've mentioned lots of great cases of Splink, but especially with all the different sources, with this master data, how do you get going without it feeling a bit too much?
I think there's potentially two approaches, and I think mostly they will spin off, starting with something that delivers value quickly, but also something that's a relatively easy target. And when I say a relatively easy target, you're looking for 2 things. You're looking for a relatively high quality of data. When we go through supporting families, things like, say, schools databases have quite good quality data because it comes out of the schools. They're seeing those children day in, day out. They're going to get the names right. If they move house, that's going to be updated quite quickly. Similarly, social care, they'll be quite on top of getting things right, but the data can get older. People will move house, and if they're no longer in contact with the department, then that address is not going to get changed. At the other end, some of the work can really be scrappy. It's a spreadsheet that's just held by a group of people doing a youth scheme. And it's, we've got some names, we've got some addresses, can you match them? We'll do our best, but generally the answer is no. So the best way of starting is towards those higher quality sections. And also simply the schools, it's bigger. It's probably going to have most of the children in the local authority. That gives you an advantage. You think you've got 2 small data sets, just the chance of there being an overlap is small. You'll only have a handful. Whereas if you think about schools to social care, unless you have a child who's not in school or is going school out of the area, you can probably assume there is going to be a match. And so that's the point where you can really start quickly with Splink and you can really get quick value. If I match schools data across the social care data, I can immediately start telling social workers about exclusions and attendance. Similarly, in the other direction, I can start telling the schools about potential safeguarding issues, and everything in between that. So there's a lot of statutory reporting and things on the edge of statutory reporting that can be useful. If you have a child in care, the local authority is parentally responsible for that child. They need to see exam results. They need to see attendance. So very quickly, you get a lot of value there. The other area I think where you can get in quite quickly with a project is deduplication, because you only need to think about one system. And that's particularly true of the social care data. It was important to get the full picture of the child. You don't want the data split between records, but it can and it does happen. Someone phones into the call center, they've got an emergency, they say, can you deal with something? The call center doesn't do the full due diligence to check in the record to make sure the child is already in there. They just get on with it, type in your record, there's a new one, and you've got that split. Typically, we can go with Splink, particularly if it's a social care system that we are already familiar with. We may already have the queries to shape the data to go into Splink. It can be in a matter of a few days before we've got the data coming through Splink, and we're potentially feeding back a list of hundreds of new duplicates that can be used to improve the quality of data in that source system.
You've mentioned the different technologies. How does Splink work within that environment?
Good question.
Environments.
So one of the good things about Splink is it's a Python library. Anywhere you run Python, you have a really good chance of running Splink. All you need is that platform, you need Splink, and then you need something under the back end to handle the data processing. Splink generates what it needs to do, but it's going to fall back to a database behind that to run it. The good news is there's quite flexible, and there's quite a lot of options. There are various options. PostgreSQL, it will run in Amazon Compute, it will run against MySQL. But the main two are kind of splitting the high level and the low level. Towards the low level, there's DuckDB. DuckDB is another open source product. It runs within Python. It's a really good quality analytical database tool. So as long as you have a reasonable quality laptop, you can plug in Splink, you can plug in DuckDB, and you can be away going locally. You can take DuckDB into the cloud. The recommendation from the Ministry of Justice is if you've got 1 million records or so, there's no need to go any further than DuckDB. But if you do need to go further, if you're that Ministry of Justice scenario where you've got 100 million people, I'm told there's a company in the US that's deduplicating products with over 750 million rows going into Splink. At that point, you need a lot more, and then you're probably talking about Spark clusters. So again, you can replug Splink. It's the same logic, it's the same rules, and now the back end, instead of running DuckDB with millions of rows, you can run it on Spark. And Spark, as you know, it can scale as long as you've got the money for the clusters. It can go as far as you want. We will typically run it on clusters of 4 or 5 machines with 4 or 5 cores each. But if you want to go to hundreds to really get that scale, the possibility is there.
And would you say there are any final big advantages of Splink and why we should be using that as our technology?
I think really it harks back to those original goals of the Ministry of Justice. It's open source, it's free, which makes it really good value. In some ways, it's unfair to compare it to the commercial competition. You're talking about sort of corporate tier master data management tools, because those will come with more. They will come with tools for kind of conforming team names, product names. They will come with an interface. They will come with auditability. Splink only takes a very narrow shot of it, but sometimes that's all you need. And those products you'll be looking at, if you're lucky, £30,000 a year, but probably much more. You're looking at that £100,000 a year, if not more. Whereas Splink, once it's in place and running, it's virtually free. For a customer recently, we tried to monitor the costs to check how much an individual Splink run would take. I think this was running on Azure Synapse Analytics, and it wound up coming in at under £5 to do that full matching process. So even if you're running it every day, you're several orders of magnitude down in terms of cost saving.
Great. Thank you very much, Barney. Thank you for joining. If you've got any questions or want to find out about any of the resources, then have a look in the description of the video or put a comment down below and we'll try to answer it. But thank you very much, Barney, or Barnabas, or Bernie, whichever one we decide to use.
Thank you.
Now we can link them all together. So thank you very much for joining. Don't forget to like and subscribe, and then we'll see you next time. Bye.
Bye.